This is video explainer 3 from week 4. We're going to be answering a question from homework number 3. The question is a 10-gram bullet traveling at 450 meters per second strikes a 10 kilogram, 1.2 meter wide door at the edge opposite the hinge. The bullet embeds itself in the door, causing the door to swing open. And then we're going to be answering the question, what is the angular velocity of the door just after the impact? So first I drew out a diagram to show what is going on in the situation. So a 10-gram bullet is traveling in this direction at 450 meters per second, and then this door, which is 10 kilograms and is about 1.2 meters wide, is embedded by the bullet, and it swings open in this direction due to the force of the bullet. So first we're going to be solving for the angular momentum of the bullet and the door. So the angular momentum can be expressed through this equation where L equals mvr, where m stands for the mass of the bullet, v stands for the velocity of the bullet, and r stands for the width of the door. So we plug in those variables, we convert grams to kilograms for the mass of the bullet, so we get 0.010 kilograms times 450 meters per second times 1.2 meters for the width of the door, and we get an angular momentum of 5.4 kilograms times meters squared per second. And next we're going to be solving for the moment of inertia. So the moment of inertia, the net moment of inertia, is going to be the combined moment of inertia of the bullet and the door. So the net moment of inertia is equal to 1/3 times the mass of the door times the width of the door squared, plus the mass of the bullet times the width of the door squared. So I plug in those variables, I multiply out and add the two sums together. So I get a moment of inertia at 4.8144 kilograms times meter squared. And so we solve for these two variables because now we can use this equation, which is the angular momentum equals angular velocity times moment of inertia. And so we know that we're going to be solving for the angular velocity, which is this variable over here. We can rearrange the equation to equal angular velocity equals L divided by I. And since we solve for both L and I, we can plug those variables in. And so we get an angular velocity of about 1.122 radians per second. And so the primary concepts that are involved in this problem is angular momentum and the fact that the total angular momentum of a closed system will remain constant, and it has both a direction and a magnitude, and the angular momentum is conserved. And the moment of inertia is the opposition that the object exhibits after having its rotation changed about an axis due to the torque of the turning force. And so yeah, those are the concepts involved. I would say the tricky parts are just figuring out how to get to the final step and which variables need to be solved for first. But after figuring out the order, it's pretty simple to rearrange the angular velocity equation and figure out what the actual velocity is. Thank you.